will be geometry lesson 1.4. Just remember at any time along this video that you need to pause to write down definitions, please do. I'm just going to kind of go through, put them up, and just keep going. So we will begin with the definition of what a ray is. A ray is a part of a line with one endpoint. So we looked at a line as being continuous in both directions forever and ever. But if we look at what a ray is part of a line, so we could extend this way, but we're really just looking from this point right here on that way in one direction. Alright, so with this guy over here, this ray, we have 3 points. M is the end point, and then we have 2 other points on there, so we could name this guy 2 different ways. Now, we had lines, so MP would be going this way as well. Then we had segments where we could just actually look at the distance from M to O. Now, today what we're going to look at is we're going to look at going here forever and ever in one direction. So we would call this guy a new symbol, ray MO. So ray MO, or we could call it ray MP because it also goes through P. Now, I always think of this when I hear the word ray. I think of a sun ray. A sun ray starts at the sun, goes on forever and ever until it hits something like the earth, but even then it's reflected and keeps going. Well, some of it is. But we can go down here. Rays are named by the 2 letters in the endpoint that comes first. So when we were looking at lines, it didn't matter on this one. Like we could have called it line MP or line PM. That's the same name. Same thing with a segment. We could call it segment MO or segment OM. With a ray, we must start at that end point, which we could call a start point, I guess, too, but we must start there. I can't call this ray OM because I'm not going that way starting at O through N. Okay, so I can't call it that way because it doesn't go that way. So rays are specific to what the endpoint is, must come first. Okay, so we want to name the ray at the right. We already named this ray. We named it ray MO, or you can name it ray MP because it also goes through P in that direction. Now we want to draw QT, no problem. So you can get your geometer out. You can plop that down. Now remembering that a ray has a starting point, and in this case, the end point is Q. Because Q is not underneath the arrowhead, Q is where it starts, and it will go forever and ever in that one direction, and somewhere along here, it will go through T. Okay, so that is ray QT. Isn't it so QT? All right, so we have the ray here, starts at Q, goes through T forever and ever, amen. All right, now angles, we're going to look at these. What is an angle? An angle is simply formed by 2 or more rays with a common endpoint. So we look at this angle over here, we have this common endpoint, here's a ray, that's the angle. And what you got to understand is that yes, we can also extend this way, we could extend this way, and we could look at more beyond over here if we added this ray, and all that. Okay, so that's what an angle is. The sides of an angle are the rays that make up the angle, and the vertex of an angle is that common endpoint. Okay, the common endpoint of the rays that formed here. So if we look at this, the vertex of this guy would be point A. Now remember, we don't have to write out point A, we can just call it A. The sides of this guy down here, we go here from A to B, that's a side over here. So we would name this ray AB. So that would be one side, ray AB. What's the other side? Ray AC. Notice what comes first in both those. That vertex comes first when we're naming the sides. So this is side AB, and this is side AC, and they are both rays. So ray AB, ray BC. All right. Now, naming these, we're going to have to name these guys. And naming these, we can do it 3 ways when we have just a single angle, meaning here's an angle by itself. Not like this. Most of you probably see 3 angles, but there's actually many more than 3 angles. There's 1, 2, 3 like numbered, but then you also have those 2 combined. That would form another angle. These 2 combined would form another angle. We could look at all of them combined. We could even go this way combined. So we have multiple angles around here. So on these I want to be more specific on. This one, the first way we can do is we can just name it with the vertex. And we're going to put our angle symbol, which is this little guy with a little arc mark through it, into the vertex. And in this case, the vertex is A. So we could call this angle A. Now, we can't do that down here. I don't want to call this angle R because I've got all those angles around there. Now, number 2, which is the best way, is we can use our angle symbol again, and then we can use 3 letters on there. Just remember that the vertex must be in the middle. So we trace along it here. We start out here on a ray, and we go B to A to C. B to A to C. So we call this angle BAC. Or you could go backwards. Just remember that that vertex needs to be in the middle. So we go angle CAB. We can't go ACB. This is what I always see, because if I see from A to C to B, I'm talking about this guy over here. We don't want that. So keep the vertex in the middle. Now the other way we can do it, and we'll see this as well throughout the year, that we can use a number designated number near the vertex to designate that angle. So right here we have this, so we could also just call this angle 1. Remember that we're always just going to use our angle symbol. So if you are naming an angle, you must use the angle symbol. Okay. So now when you have multiple angles like this, guys, this is the way to do it. Okay, you have to do it like this. This is the best way to do it, unless like over here we do have those numbers. See, the thing is I could actually name this angle, but I can't use angle 1 and 2 combined. I don't want to say that. I would use S to R to Q. So that's what that angle with 1 and 2 would be called. Alright, so that's naming angles. Now, naming angles, please don't get that confused with this, which is classifying. Well, we'll get to classifying here in a second. Alright, measuring an angle, you need to be able to use your geometer, so pause this and get your geometer out. Now here's my 360 geometer. So when we measure angles, what we need to do is the point that's right here in the center, that hole that's kind of in the coordinate plane of your protractor, that always goes right on the vertex of the angle you're measuring. Right on the vertex, put that hole in there. And then what you do is you kind of rotate your vertex and you zero that out. So you have 0 lined up with one of the sides of your protractor. And then what you can do is you can draw that out, and you can see that, hey, that goes out here and hits at about, 35 degrees. So here's the proper notation. We say the measure of angle BAC is 35, and we always label degrees. Now some of you might find that this segment, this ray, doesn't come out far enough and it doesn't hit these little tick marks out here. If that's the case, you need to lay your straight edge on there and just extend that side way out. And that might be a good thing to do right off the bat. Okay? But if you lay your protractor on there and that's too short, then you need to do that so you're precise. I think when you measure angles, and I have you measure angles, you should be within 2 degrees of what I measure. So you could go up to 37 or down to 33, but you should be in the ballpark. Now drawing angles is easy with your geometer, okay, with your protractor and your geometer. So if we want to draw angle XYZ, we're going to have those 3 points on there when we're done. It's going to look just like this, maybe not less the number. We want it to measure 80. So what we do is we just plop our geometer down, make a mark right here, right where the vertex is. So that's where the vertex is going to go. It doesn't matter how it's turned, whatever. Go over here, make a mark at 0. Now you have those little slots in there that you just got to make a mark right there at 0. And then all you do is you start counting up 10, 20, 30, 40, 50, 60, go all the way up to 80. You know, mine is a two-sided protractor. Yours is not. You just count one way. That's it. Mine counts up and counts down. Well, notice what's 180? 100 plus 80 is 180. 110 plus 70, 180. 120 plus 60. So you're kind of going the other way. So there we go. And then you can remove your protractor, and you have those 3 points, and you can go ahead and connect them. Now you don't have to connect these two this way. And then remember, these are rays, so we're going to go ahead and put our arrowheads on there, all that good stuff. And I always like to put that, when I draw an angle, I always like to say, hey, that's an 80-degree angle there. Now, we're not done yet. We need to draw angle XYZ. The most important one is the Y. That's your vertex. That goes right here. And then X and Z are kind of interchangeable wherever you want. X, Z. So we have angle XYZ is equal to 80 degrees. Okay. So now we can go ahead and look at classifying. Now that's not naming these. This was naming. This was angle XYZ. This was angle BAC. Okay, that's naming. This is classifying. So we have three types of angles we'll look at. We'll look at a right angle, which is equal to 90. We will look at an acute angle, which is anything less than 90. And we'll look at an obtuse angle. Obtuse is anything that's above 90 degrees, but less than 180. We could, if we wanted to, throw a third one in there, which is a straight angle. Some math teachers teach it, some don't. I don't really care. Guess what a straight angle is? It's a line where you have rays going in each direction. And sometimes we could talk about this as being opposite rays. So we have one ray going that way, we have one ray going that way. Take a wild guess what the degree measure that is. That's going to be equal to 180. So anytime you see a line for the rest of the year, it's going to be 180 degrees. All right. So what we need to do is we need to measure these and classify them. So we can classify these. So let's look here. Now, guys, we need to work on finding these angles first. We're looking at MPR. So we're starting at M. We're going through P to R. So that would be this guy right here. Now, that is obviously an obtuse angle. Now, you can plop your protractor down there and measure it if you want. So let's go RPM. Let's look at RPM. I'm just going to classify them. You can measure them. R, starting at R, to P, through P, to N. That's this guy right here. Well, what's the degree measure there? We don't even have to measure that one. It's got the box there. Remember, that box is how we are always going to show a right angle. That is a right angle. So its degree measure is 90 degrees. We're into that. Now, NPS. So we go start at N. We go through P to S. And that's within that 90 degree angle. So that is less than 90 degree, and that would be acute and whatever you measure that at. Next ones, congruent angles. Angles that have the same measure are congruent. Now, this is kind of a goofy geometry thing right here, but when we talk about congruency, we talk about shapes. Angles are congruent. Shapes are congruent. Squares are congruent to squares. Triangles are congruent to triangles. Measures are equal. So if I measure the angles and they're the same, they're equal, and the angles are congruent. Just like with segments we talked about last class. Now, so if angle MPN, this is naming the angle, if this angle, there's our congruent symbol, is congruent to angle RPN, well then their measures are equal. Okay, so measures are equal, shapes and angles and segments, and those are congruent. So we look over here, this angle right here, and we have these little arc marks which simply show that these two angles are equal. The angles are congruent, the measures are equal. Angle bisector, to me when you hear the word bisect, that means two sections. Bisector means cut to two equal parts. So an angle bisector, again you can pause this if you need to get that written down, a ray that divides an angle into two congruent angles. So if we look at this guy over here, this is an angle bisector. If PN, ray PN is an angle bisector, it cuts this into two equal parts. So if this angle right here is 50 degrees, that means that this angle over here has to be 50 degrees. So what's the entire angle all the way through? That'd be 100 degrees. Now, on the flip side of that, let's say that this entire angle was 120 to begin with. Well, what are each of the smaller angles in? Well, you cut 120 in half and you get 60 degrees and 60 degrees. Right? So that's what we're going to use for these problems down here. So let's go to problem number 3. Let's read the directions because we have some given stuff right here in the directions. In the figure, ray BA, we need to know how to read these. Ray BA and ray BC are opposite rays, meaning they're going in opposite directions. And these two guys are in opposite directions, and they form a line which is 180 degrees. So now when we look at this, we say that at BF, which is this ray right here, bisects C to B to E. Bisects this angle right here. Notice we're all over here. I don't care about that stuff. They don't talk about any of that stuff. I'm going to get rid of all that stuff. And I'm just going to zone in on this side and look at this. All right. So this ray bisects this angle, which means that these two angles right here, 3 and 4, are actually congruent. So what I'm going to do is I'm just going to show that. I'm going to say that angle 3 is congruent to angle 4, which means they have the same measure. So if this is 40, this is 40, so on. Now let's go ahead and read that. That was given and for both these problems. Let's read this. EBF, measure of angle EBF, that's E to B to F. This angle right here is 6x plus 4. So I'm going to put that in there, 6x plus 4. And then measure CBF, that's this angle right here. CBF is 7x minus 2. So I'm going to put that in here, 7x minus 2. So we said that this was bisected. We said that this big angle CBE was cut into two equal parts. That means that these two parts right here are congruent, are equal. Now, angle 3 is a measure of 6x plus 4. So instead of having angle 3 here, I'm going to go ahead and write the measure at 6x plus 4. Measures are equal. Angle 4 had a measure of 7x minus 2. So what we can say there is that since those angles were congruent, those measures are just equal because they're cut in two equal parts because it's bisected. So now what we got to do is solve this. Let's do some quick algebra. Minus 6x, Gandhi. Add 2, Gandhi. 6 equals x. I'm going to use the symmetric property of equality to flip-flop that. X equals 6. Okay, so we found the value of x for that drawing now. Now we have to go back and answer a question. Okay, the question didn't ask what's x. The question asked, find the measure of angle EBF. So we need to look at EBF. Here is what EBF is. The measure of angle EBF is 6x plus 4. Well, we know x. So what we're going to do is we're going to go 6 times 6, because that's what x is, plus 4. 36 plus 4 is 40. So we can say that the measure of angle EBF is 40 degrees. There's your answer, okay, because that's what it was asked for. Now, how do we check ourselves real quick? EBF is this angle right here. We found this to be 40 degrees. We found this angle up here to be 40 degrees. Well, because this is bisected, that means if this is 40, this guy over here should be 40. Well, let's check. 7 times 6 is 42. 42 minus 2 is 40. So we know without a doubt now that we did it right. We're good to go. So let's go over to 5. Same process, different numbers, though, different values. Now let's go with what's given in the reading up here. So let's read it. Same thing. It says, hey, ray BA, BC are opposite rays, so that's a line, no problem. BF, this one right here, that ray right there, bisects CBE, so bisects this. This is the same thing as last time. So we know that angle 3 and angle 4 are congruent. We're not using any of this stuff over here, so don't care about that. So we're going to go ahead and set it up. And so we know that angle 3 is congruent to angle 4. Now, you don't necessarily have to write this every time. I just like to do that. So that's given up here in this information. Now let's go read the problem. Angle 3, this angle right here where angle 3 is, this is nicer than trying to have to hunt down that EBF like last time. Angle 3 is 6y plus 2. And angle 4 is 8y minus 14. 8y minus 14. Now, right here we knew that these two angles were congruent, so these two measures will be equal because it's a bisector. So angle 3 is 6y plus 2. Angle measures are equal to angle 4, which is 8y minus 14. Quick solve, I'm going to subtract 6y. Gandhi. At the same time, I'm going to add 14. Gandhi. 16 equals 2y. Y equals 8. There we go. All right, now again, what we need to make sure we do is we go back up and answer the question. The question says, find measure of angle CBE. Now, what we need to be heads up on is CBE is actually the entire thing there. All right, so we got to do a little extra work right here. So let's go ahead and find one of these angles. If we find one, we know the other, and if we know both of them, we just add them together. All right, so let's go up here. I'm going to go 6y plus 2. So angle 3 equals 6y plus 2. So angle 3 equals 6 times 8, which is 48 plus 2. 48 plus 2, angle 3 is 50 degrees. So this angle right here is 50 degrees. Let's go ahead and double check ourselves just to make sure. So let's substitute 8 in there. 8 times 8 is 64. 64 minus 14 goes right back to 50, so we're right. Now remember, what we wanted, we didn't want angle 3 and angle 4. We wanted what's the entire thing. Well, here to here's 50, here to here's 50. 50 and 50 makes 100. So the measure of angle CBE equals 100 degrees. That's your final answer. That's what we wanted to find. Okay, same process over here. Let's look at this. Let's read what's given. It says figure ray QP, ray QR, opposite rays, so that's a line. So that's a line. And QS bisects PQT. So here is PQT. QS is a bisector. So we know that this angle is congruent to this angle. Okay, by definition of what bisector is, we know that those two angles are congruent. Now, let's go ahead and read the problem. PQT is the entire thing. This entire thing is 60, so let's think a little bit. This entire thing is 60. What are each of these smaller angles that were bisected? Well, that would be 30 degrees, and that would be 30 degrees. Right? So we thought through that. That's given, and that's the definition of bisector. So if we look at this, PQS is 4x plus 14. So PQS is 4x plus 14. Okay. So we know that PQS is 4x plus 14. Now, if you look at that, we know what that angle is. We know that that 4x plus 14 should be 30. So there's our equation right there. We know that 4x plus 14 should equal 30. There's the equation. Now we just go ahead and subtract that, so we get 4x equals 16, x equals 4. There's our answer. Now let's look, is that all we needed? What's the question asked for? It just says find the value of x. We found x, we're done. We're done. Okay, let's go over here. Number 11, last one. Same process here. Let's look at what's given. What's given is the same stuff over here, that these are opposite rays, that's a line, and QS is a bisector of PQT, so we can mark this angle congruent to this angle. Right, so we know that those two are equal. Now this says that PQS is 3x. We don't have that 60 anymore. We don't have that. This says that PQS is 3x plus 13. Okay, and we know that this PQS is equal to whatever this angle is up here. SQT, which is this smaller angle over here, is 6x minus 2. And we knew that these two angles were congruent, so their measures, which those are the measures, are equal. So we would say that 3x plus 13 equals 6x minus 2, and we can solve that now to find x, but remembering that our answer is not x, our answer is what the measure of angle PQT is. So we solve that real quick. Minus 3x, Gandhi, add 2, Gandhi, we get 15 equals 3x, x equals 5. So x equals 5 is our solution, but again, we don't want x. We need it, but that's not our answer. We want PQT, which again is the whole thing. So I'm going to find the parts. So I'm going to go ahead and take that 5. I'm going to come up here and substitute it in. So I'm going to go angle PQS equals 3 times 5, not x, times 5, plus 13. That's 15 plus 13, which is 28. So PQS is 28 degrees. That means that this angle right here is 28 degrees, which means this angle over here is also 28 degrees. So the entire thing is 28 and 28, which is 56. So our final answer is the measure of angle PQT is 56. Do not forget to label degrees. All right, so there you go. If you have any questions on that, please come see me. You can also come check your answers to make sure you're doing it right. Good luck, and we will see you next class.